So, when you have problems that say, solve the triangle, and we'll have a few of these here in the next few days. So if it says solve the triangle, that means you want to find everything that you're missing. Okay? So we find all missing measurements. Okay? So we want to find all of our missing sides, all of our missing angles. Okay. So, it'll say something like, given triangle ABC, where angle C is a right angle, solve the triangle. So, today, and from here on out, sometimes it won't give you the actual triangle. It'll just give you measurements. So, if you have capital letters, those are always angles. So, capital letters are angles. So in this one, triangle ABC, capital A, capital B, capital C, those are our angles. And then lowercase letters are sides. And they'll match. So if you have a big A, big B, big C, you'll have little a, little b, little c. So capital letters are angles, lowercase letters are sides. And like I said, we'll do that today, and we'll do that for the next few days. So let's look at one. So let's say it tells me big A is 37 degrees and little b is 6. So, I always like to draw a triangle. I think it helps just keep everything straight. So, I'm going to draw a right triangle. And it already told me that C was my right angle. So, it does not matter where you put A and where you put B, okay? You can put A at the top, you can put B at the top, it don't matter. I'm going to put A at the top and B at the bottom. Okay? So, what really matters is where you put your sides. So, our sides, little a, little b, and little c, are always across from their capital letter. So, if A is up here at the top, the opposite of that is little a. Okay? So if big B is down here, opposite of that is always little b. And then C is our right angle across from it. Our hypotenuse today is little c. Okay, so your lowercase are always opposite of the big ones. Any questions on that? Alright, so let's fill in what we know. So it tells me that A is 37. And that's an angle because it is capital. And B, little b, is 6. Okay, so that's an angle and a side. Any questions so far? Alrighty, so if I'm looking at my angles, I have big A, I have big C, so I need to find big B. How can I do that? Good. So I know all of my angles have to add up to be 180. So I can do 180 minus, and just add those up. 90 plus 37. So then what does B equal? You got it. It told me. So it told me A was 37, and big A was 37, and little b was 6. Okay, so to find the sides, though, we have to do trig. So we want to label the triangle, but you always label it based off of a certain angle. So you can do the 37, you can do the 53, it don't matter. You get the same answer. I'm going to do 37 just because that's what they gave us. So I'm going to say 37 is my important angle. So I'm going to label it. Here's my right angle. So C is always the hypotenuse no matter what. If I draw my line, little a is the opposite, and then B is the adjacent. Questions on that? So now we want to find A, we want to find C, no matter whichever one you want to find first. Let's go ahead and find A. So if I want to find little a, I know that's the opposite. The only side I know is adjacent. So which trig function is opposite and adjacent? Tan. Good. So we want to do tan of our angle, which is 37, equals, and then opposite over adjacent, so little a over 6. And then this one's easy, same thing we did yesterday. Solve for A, so just multiply by 6. Just make sure your calculators are in degree mode. Remember to do that, you go to mode beside the blue button, and it's the third line down. So 6 tan of 37, and we get 5.52. Just kidding, 4.52. I don't know why I said 5. Questions? How can I find C, little c? Yeah, so I can use cosine. So cosine of 37 equals, and then cosine is A adjacent over hypotenuse. Our adjacent is 6, our hypotenuse we don't know, so 6 over little c. So again, solving it like we did yesterday, we have to move that little c, so multiply both sides by little c. And then to get c by itself, we divide by cosine. And what do you get? Good. 7.52. Is there another way I could have found C? Good. So we also could have done Pythagorean theorem. Good. So if we did Pythagorean theorem, we would say 4.52 squared plus 6 squared. So 4.52 squared plus 6 squared gives us that. And then if we do square root of that, we get 7.51, which is the same thing that we got when we did trig. So either way, you get the same answer. So I'll tell you that in a minute. Alright, any questions on this? And I know we've already done them for our weekly homework, so hopefully it's not too bad. So let's look at applications. So in trig applications, you're just drawing a picture of what's happening. So sometimes it'll tell you everything that you need to know. It'll tell you what angle and stuff, but sometimes it says angle of elevation or angle of depression. So if it says those words, then what you're doing is you're drawing your triangle based off of the eye level of something. Okay? So if you're standing down here at the bottom of this triangle, and let's say this is a building, and you're looking up at the top of this building. If you think about your eyes looking straight, and then you're looking up, this is the angle that changes. Okay? So that is the angle of elevation. Okay? So if it says angle of elevation, you do your eye level and you're looking up. And so this down here is the one, they're both changing, but this is the one that's changing with your eyes. So then it also could say angle of depression. So if you're standing on top up here, if you're looking straight, you're looking this way. Okay? And so if you're looking straight and then you look down at something, this is your angle that changes. So that is your angle of depression, is what that's called. Okay. So angle of elevation, angle of depression, you're always drawing it from your eye level, and then if you're looking down, or your eye level and you're looking up. Okay. And you don't always have to use that, just if it has that vocabulary in it. So let's look at one. So our first one says a 20-foot ladder leans against a wall. The base of the ladder is 3 feet from the wall. We want to know what angle does the ladder make with the ground. So the first thing you want to do is draw a picture. So we have a ladder, and it's leaning up against this wall right here. And so the problem tells me that it's a 20-foot ladder. So that's the length of our ladder. And it tells me the base of the ladder is 3 feet from the wall. So the base of the ladder is here to the wall is 3 feet. And then your wall and your floor should make a right angle. Hopefully. So then I'm trying to figure out what angle does the ladder make with the ground. So am I trying to find the top angle or the bottom angle? Bottom, good, because we want the ladder and the ground. Any questions setting it up? Okay, so now we just solve it like we did yesterday. So here's our right angle, so our ladder is our hypotenuse. X, if we go across, takes us to the opposite, which is our wall. So then our adjacent is the floor. Or the ground, whatever. So if I'm trying to find X, which trig function should I use? Good, cosine. So cosine of X, because we don't know the angle, that's what we're trying to find. But it's A over H. So 3 over 20. How do I solve for X? Good. Do the inverse. So we do inverse cosine. And we type that in our calculator, and what do we get? Good. 81.37 degrees. So, I'm probably not going to get on that ladder because it's almost straight up, but I'll leave that up to you. Any questions on that? Alright, let's do one more. Okay, so this one we want to know how tall is a bridge if a 6-foot tall person, or a 6-foot person, standing 100 feet away can see the top of the bridge at an angle of elevation of 30 degrees. So again, we want to draw a picture. So we have this bridge. I'm not the best at drawing bridges. It's fine. So we have a bridge, and we have this person over here. So it tells me that this person is 6 feet tall. And it also tells me that he's 100 foot away from the bridge, but they're looking at an angle of 30 degrees. So, since it's an angle of 30 degrees and that's where he's looking, we want to draw our triangle from his eyeballs to the bridge. Okay? And it tells me that this person is 100 feet away. It also tells me that they're looking up. So their angle of elevation, they're looking up at an angle of 30 to the top. So to the top, to their eyeballs, is 30 degrees. And so we want to know how tall is the bridge. Oh, gosh. Any questions on drawing it? Other than, why can't you draw a bridge? Alright, so we label it. So here's our right angle. So here's our hypotenuse. If we go across from our 30, opposite, that's what we're looking for. And then the 100 is our adjacent. So, what trig function do I use? Tan, good. So, we do tan of 30. And then tan is O over A, so X over 100. So to solve it, what do? Good. Times 100 on both sides. And then we can just type that in our calculator. And we get 57.74. So, is that the height of the bridge? No, why? Because he's 6 feet off the ground. Now, we don't know his eyeballs exactly where they are off the ground. But we'll assume that his eyes are on top of his head. And so, we have to add in his 6 feet. So, then the bridge actually is about 63.74 feet. Okay. Maybe not. Maybe just like 61. Yeah. Yeah. Yeah, something like that. Okay, any questions on this?